Okay, we have been looking at proving two triangles similar. We have looked at two different ways to prove triangles are similar. One way was when you're given two triangles and you know their corresponding side lengths, you can prove they are similar or not similar by looking at the ratios of corresponding sides. This side 4 corresponds to this side 8, so I can create a ratio of 4/8 comparing those two sides. This triangle 5 corresponds to 10 and 7 corresponds to 14. So if I create ratios comparing the corresponding sides, I get 4:8, 5:10, and 7:14. If I reduce all three of those ratios, they all equal 1/2. I can say that these two triangles are similar because the corresponding side lengths share a common ratio of 1/2. Yesterday, we looked at another way of proving two triangles similar, and that was by something called the angle-angle criterion. With the angle-angle criterion, you need to show that two pairs of corresponding sides are, two pairs of corresponding angles congruent. For example, angle A is congruent to angle A prime, and angle B is congruent to angle B prime. Because of this, we can say that these two triangles are similar by what we call the angle-angle criterion. I want you to take a look at this triangle. I have triangle OPQ with side lengths 4, 6, and 9. I took that triangle and I dilated it by a scale factor of 3, creating this new triangle. This new triangle, you'll notice, has side lengths 12 and 18. I multiplied the 4 by 3 and the 6 by 3. It also has this side of 27 over here, which is 9 times 3. Angle O stayed congruent because I dilated my figure, therefore this angle stays congruent. So we know that these two triangles are similar because I dilated it. What if I went back to my triangle that has side lengths 4 and 6 and I extended both these sides by scale factor of 3, so 4 becomes 12 and 6 becomes 18, but I kind of squished my triangle in. I might get something like this. You can see that angle O and angle O prime are not congruent. Therefore, these two triangles are not similar. However, the sides are in the same ratio. 4 is to 12 as 6 is to 18, just like in this triangle. So the question becomes, if I know two side lengths on two sets of triangles, two pairs of triangles, do I know or can I prove that those two triangles are similar? At this point, pause the video and get note page 106 in front of you. Okay, I'd like to take a look at question number 1. Given the information provided, is triangle ABC similar to triangle DEF? So the question becomes, can we say that do we know that these two triangles are similar? So let's take a look. I have side length 2 here and side length 1 here. I have side length 6 and side length 3. Let's create ratios of those side lengths. I'm going to go from this triangle to this triangle. So I have 2 to 1, and then I have 6 to 3. Are those two ratios the same? Sure. 2 over 1 is 2, and 6 divided by 3 is 2. So my two sets of corresponding sides share a common ratio. I don't know my third side length, so I can't check that. But you will notice that this angle, 39 here, stayed 39 here. So that means there was a dilation that took points B and C to points E and F, or from E and F to B and C. Because those angles stayed the same, and there's a common ratio between the corresponding sides, I can say that these two triangles are similar. Now, let's talk about what we need to say to informally show that. To informally show that, we are going to say that angle A is congruent to angle D because they both equal 39 degrees. And we're going to say that 2 over 1 is equal to 6 over 3. Now, because of these two things, we can say that triangle ABC is similar to triangle DEF. What I want you to note is it is important that the congruent angle has to be included in between the two pairs of corresponding sides that are in proportion. So we call this the side angle side criterion, because you have a side, an angle that's included, and another side that you use to prove that the two triangles are similar. It is important that this be an included angle. In other words, the angle that's congruent has to be the angle between the two pairs of corresponding sides that are in proportion. Okay, let's take a look at question number 2. Question number 2 has a triangle inside another triangle. So we're trying to see if ABC is similar to A, B prime, C prime. Well, I don't know the length of this side or this side, so I can't look at the 3 side lengths. But I have some side lengths, and I do know they share a common angle. This angle A is the same in both triangles. Both triangle ABC and A, B prime, C prime share triangle A. So they have one congruent angle. Now I'm going to look at the side lengths to see if I can see if they share common ratios. So let's take this side length of this triangle, which is 4.9, and compare it to its corresponding side of the big triangle, which would be this one here. That side length is 8. Let's look at the other side of the triangle. I know this is 2.7, and I know this is 7.1. Are those two things congruent? Is 4.9 over 8 the same as 2.7 over 7.1? Pause the video here, put them into your calculator, and check. Okay, I'm assuming you've done that, and you would know that no, they are not equal to each other. This means that these side lengths are not in proportion. Therefore, these two triangles are not similar. So we're going to state, no, they're not similar. Because, and just showing the two side lengths are not congruent is enough information to prove that those are not similar triangles. Let's take a quick look at number 3 together. Given that triangle ABC is similar to triangle A, B prime, C prime, could we determine the length of AB? First of all, what does it mean to say that the triangles are similar? Because they are similar, I know that corresponding sides are in proportion, and I know that the angles are all congruent. So, let's take a look at this question. This question tells us they're similar, so that means corresponding side lengths are in proportion. I can use that to create a ratio. I'm going to take this big long side, which corresponds to this side, and I'm going to make a ratio of AC prime to AC, which is 15 to 5, or 3. 3 is what we call our scale factor here. Because they're similar triangles, we know there's a scale factor. Since I know this,
to the main office, please.
Since I know that my scale factor is 3, I can use this to find side length AB prime. Side AB is 2, multiply that by its scale factor, that gives me 6. So the length of AB prime is 6. Let's take a look at one more problem together. It's question number 4. If we suppose that xy is parallel to x prime y prime, we can use the information provided to determine if OXY is similar to O x prime y prime. So let's take a look at that. Because this side is similar to this side, or excuse me, parallel to this side, because those are parallel, we know that a dilation happened. A dilation took xy out to x prime y prime from center O. Because there's a dilation, that means that those two triangles are similar. Because they are similar, I can now use that information to find the length of OX prime and OY prime. At this point, I'm done with the tutorial. You can continue on, complete this packet by yourself. So complete No page 106. Find a partner to check in with. Make sure you agree. Then ask the teacher for No page 107. You're going to work on No page 107 in class. What you don't finish in class will be homework. I hope this went well.